Okay. Um, my name is Justin. I'm a part of group 119, and this is my final project for CS 564. So my data set specifically that I chose was the Steam uh, game data set, where through the Steam API, this data was scalped and it has many columns, some of which I did throw out because they weren't as useful or as nice looking to what I was planning to use the data for. Okay, so before we dive into um, my findings, I'm going to go through each graph or chart rather and explain what each is used for. So starting from the top row on the left side, we have two bar charts. The first one is a bar chart of the release year versus how many games were released that specific year. And these bars are clickable along with the dots as well. The dots are there because for these specific years, the number of games are so low in comparison to these other years that it was kind of hard to click on the graph, so I included the dots. And this limits what data is displayed on the screen. So like for instance, if I select 2021, you can see it updates all the other charts as well to include only the data from 2021. You could click on it again to remove it, and if nothing is selected, then it reverts back to having the entire data set. But we could have multiple years selected. For instance, 2006, you could see it updates all the data accordingly. And I can also include 2007 data, 2008 data, and it slowly, one by one, inputs more and more and more data depending on what you have selected. And once again, you can remove and remove and remove. Now, as you can see, as I selected different data, let's say 2016, for instance, it updates whatever the top green selected one here is. So if I remove it, you can see it's Hogwarts Legacy. Then I select, then it's Hearts of Iron 4. Now moving on to this, like I said before, it was updating this, but this graph shows the top 20 games in terms of CCU of whatever year is selected. If nothing is selected, it's the whole data set. So in the whole data set, it's Hogwarts Legacy. And we could select, once again, different games to reveal the information. And as you can see, it's updating on the bottom right. So let's say I swap over to Counter-Strike. It updates the information in this table to display what these columns or attributes are for the game. So as you can see, the peak CCU is 825,000. If I swap over to, let's say, Elden Ring, the peak CCU is 46,000. And this data updates accordingly. The purpose of the table is just to look at the data and look at everything pertaining to a specific game entry. And also these radio buttons, which I will explain in about 2 seconds. So now moving on, we have two scatter plots. The first one is specifically a peak CCU versus Metacritic score, or rather some variable that can be changed. These scatter plots support brushing, so if you want to look at specifically this peak CCU, you could brush it, and then as you can see, it updates the other displays accordingly. If you want to reset it, you just simply click, and as long as it selects nothing, then it resets it. Now, moving on to the next scatter plots. This is a general scatter plot that the user can determine what the X and Y variables are. The values that you see here, Metacritic score, price, and estimated owners, these are the default values that I have selected once you load up this dashboard. However, the way you change it is by looking at the table. I have radio buttons and labels for these two scatter plots. So this one's S1, this one's S2. So we could change the X variable for S1 by simply clicking. So let's say I want to change it to peak CCU. Then I simply click on the radio button and it updates it accordingly. If I want to move back to Metacritic score, which is what I'm going to leave it at for the purpose of explaining findings, and I can change that. Same thing here. I could change price to something else. So in this case, this is the y-axis. So let's change price to peak CCU, maybe, just for the sake of showing it. Then once again, it updates accordingly, and X as well. You could change the X variable, and it will update it accordingly. Now, if we move on to the parallel coordinates plot, this is a basic parallel coordinates plot. It supports being able to reorder axes by clicking and dragging, and it supports brushing as well. If you brush and then let go, it updates the scatter plots as well and displays only the selected data in that case. All right, so now with everything out of the way, now let's go over some interesting findings that came about because of this dashboard. First and foremost, I use peak CCU as a means of measuring the popularity of a game. A high CCU, and by high I mean something over 1,000-ish, means a popular game in that case. There are cases where, like for instance, Hogwarts Legacy, the peak CCU was astronomically high in this case. Now, the amount of data in the set was large. So to restrict it, the best year that I found that was not like in the case where there were 3 games dominating, where now there's multiple games. It's 2016. So in this case, if you look at the peak CCU and look at popularity, I did not manage to select the top one. So if I select the top one, you could kind of see that all of these games, it might be a little bit hard to see under Metacritic score because it varied a lot down there, but most of them have scores of around 60 or higher in that case. So that was one thing that I noticed in this data set. A 60 or higher Metacritic score tended to lead to high peak CCU in this case. But as you look here, under positive, recommendations, and negatives, the lines that are colored in are also the lines that are near the top as well. So if I be a little bit more stringent on the peak CCU, you could kind of see that high positive, high recommendations, and high negatives also kind of relate to peak CCU. Now, the reasoning for this most likely is because a high peak CCU also led to a high estimated owners count. As you can see, most of these games are leading to around, I believe that's 1 million to 2 million. I can't, 1, 2, 3. Yeah, 20 million, I think that says. But regardless, that's a high estimated owners count. And because of that, there's a larger pool of people that are willing to recommend, or larger pool of people that are willing to put a positive or negative review in general. And that's the cause of that. Now, in terms of accessibility, I measured that in terms of Windows, Mac, and Linux. There was also a column for supported languages. However, this was a little difficult to show in a 2-dimensional plane in terms of a scatter plot. So I mainly just used Windows, Mac, and Linux. And Windows, every single game in the data set, I believe, used Windows as their main operating system. However, not all games used Mac and not all games used Linux. So in the case of True for Mac, you could see that the highest rated game, Hogwarts Legacy, did not use Mac. And then the same can be said for Linux. Hogwarts Legacy did not use Linux either. So because of this, you could kind of see that it doesn't matter what operating system they use or how accessible it is. Accessibility did not relate to popularity, and what related to popularity the most was definitely Metacritic score. And even within price, as you can see, I only highlighted the 60 to 100 range. Even within price, there was not a strong correlation as well, because a high priced item like Hogwarts Legacy, which was $60, had a high concurrent count. However, there are low numbers as well. I believe CS:GO was $15, if I remember correctly, or $10. That had a high concurrent count as well. And that ends my video. Thank you for watching.